Right, in one of our previous lessons we had a look at some general solutions to trigonometric equations. Now, one of the particular aspects of that I want to discuss today is a general solution for an equation involving a sine function. Now, in that previous lesson that we had discussed, we looked at these two formats being the general solution for the sine function, right, based on the two quadrants. That's going to give us the solution. Now, an alternate way to do the same thing is to express the general solution in this particular format, where x is equal to n pi plus minus 1 to the power of n times sine inverse of the answer that we have in the question. Right. So what I want to discuss an example where we're dealing with a situation like this to find the solutions to a particular question. So let's just jump straight into this example, right? So they've given us a trigonometric equation has a general solution, x is equal to n pi plus minus 1 to the power of n sine inverse of a half. And they want us to find all the solutions to this equation in the interval minus 2 pi, right? Now, what we can do here in this particular scenario is, all right, so, and again, we're going to follow what we did in the previous video, right? In the positive direction of the x-axis, we're going to start by substituting the value for n as 0, and in the negative direction, we're going to start substituting the value for n as minus 1. Right, now, given that this is a sine inverse function, so for example, right, if this question was written in this format, sine x is equal to 1/2, right, then x is equal to the sine inverse of a half, right? And that's what they've done here. They just represented it in a different format, right? What I can see here is sine x function has a period of 2 pi, which means we're going to be able to fit 2 cycles in this domain that we have here, right? 1 cycle on either side of the y-axis, right? So what we're going to then now do is we're going to start substituting the values for n. So I'm going to start by substituting the value for n as 0 into this equation. So x is equal to n pi plus minus 1 to the power of n times sine inverse of a half. Now, sine inverse of a half in the first quadrant, right, is for a value for theta being equal to pi on 6, right? So in other words, the simplified version of this is going to be n pi plus minus 1 to the power of n times pi on 6, right? So let's start substituting. If n is equal to 0, right, I'm going to do that here. So when n is equal to 0, right, x is going to be equal to, that value is going to be 0, right, and then minus 1 to the power of n is equal to minus 1 times pi on 6, simply minus pi on 6 is our first solution in this particular question, right? When n is equal to 1, right, so n is equal to 1, sorry, I've just realized I've just made a mistake in that previous working out. Minus 1 to the power of 0 is equal to a positive 1, which means the solution is going to be a positive pi on 6, right? So when n is equal to 1, so we're going to have x is equal to, right, 1 times pi, and then plus minus 1 to the power of n is, in this case, is 1. It's just simply going to be minus 1 times pi on 6. That's just going to be minus pi on 6, giving us our next solution, 5 pi on 6. Right, so that, I believe, is the first two solutions on the right-hand side of the x-axis. Right, now you can further go ahead and substitute n as 2 if you want. So if I substitute n as 2, right, I'm going to have x is equal to 2 pi plus something, right, which is exactly outside the domain that we're dealing with, which is minus 2 pi to 2 pi, right? So which means we don't need to worry about substituting the value for n as 2, right? So I'm just going to get rid of that, right? I still need to find out my solutions on the left-hand side of the y-axis, right? So which is why I'm going to start substituting the value for n as a minus 1. Now that's going to give me x is equal to minus pi, now plus minus 1 to the power of minus 1, right, times pi on 6, right, which is simply going to be minus pi, take away pi on 6, which is going to give us minus 7 pi on 6, and that becomes our next solution in this case, right? Then I substitute my value for n as n equals minus 2, right? X is going to be equal to minus 2 pi plus minus 1 to the power of negative 2, right, times pi on 6, right? Think about this, right? Minus 1 to the power of negative 2 is same as 1 over minus 1 to the power of 2, which is simply going to result in a positive 1, right? So which means we're going to have minus 2 pi plus pi on 6, right, which simplifies as minus 11 pi on 6, and that gives us our fourth solution for this particular question. So in other words, my solutions are x is equal to minus 11 pi on 6 minus 7 pi on 6. Then we have the other two solutions, which is pi on 6 and 5 pi on 6, and that completes this particular question. Alright, so when you're finding a general solution for a sine function, the ultimatum is you could end up using these two formats to start with, where we have both the equations, or you can use the alternate method, right? Both of them are going to result you in the exact same solution, right? The reason being, right, when we deal with an equation in this particular format, right, when the value for n is an odd number, alright, when the value for n is an odd number, the solution is simply going to look like n pi. Now minus 1 to the power of any odd number is going to be a negative 1, right? So which means take away sine inverse of a, and when n is an even number, right, the solution is going to look like this: 2n pi. Sorry, my bad, I just made a mistake there. Just n pi, right? N pi plus sine inverse of a, and that's why these two equations, they basically concise itself into this format when we're using it in the format of x is equal to n pi plus minus 1 to the power of n times sine inverse of a. Right, that concludes this short lesson. Thank you for watching, and have a lovely day.